In this video, we're going to be discussing the discriminant. So discriminant is a quadratic tool we use to find the number of solutions to a quadratic equation. So in this case, we have the general form ax squared plus bx plus c equals to 0. The discriminant is denoted by a triangle, also known as delta, and it's b squared minus 4ac. And what this tells us is the number of solutions or x-intercepts when we go into sketching to a quadratic equation. So let's take an example of how we work it out, and then we'll go through what the discriminant means. So let's say we had 2x squared minus 3x plus 1 equals to 0. The discriminant is equal to b squared, so b is negative 3, minus 4, bracket a, which is 2, and bracket c, which is 1. So that's negative 3 squared, 9, minus 4 times 2 times 1 is 8, which is 1. Okay, so in this case, for this quadratic equation, the discriminant is 1. Now we're going to go through 3 different solutions. So the discriminant, or delta, can be positive or greater than 0. It could be equal to 0, or the value could be less than 0. In this case, we have the discriminant being 1, which is a positive value, so it's greater than 0. In this case, we actually have 2 distinct solutions to our quadratic equation, or 2 x-intercepts. So how does that look on a graph? If we have a sketch here, do it in black. We have a sketch. A discriminant greater than 0 will look like this, something like that. And the important thing to highlight about this is it crosses the x-axis twice. Once here, and then once here. These are the 2 solutions. The discriminant doesn't tell us what the solutions are, just that 2 solutions exist. If the discriminant is equal to 0, that means there is 1 solution, or 1 x-intercept. Okay. Now you might think, how does a quadratic have 1 solution? It goes either across the intercept, right, or across the x-axis. It occurs like this. Oops, don't need a 3D graph. If it just touches the x-axis like this, or even a negative graph like this, it only has 1 x-intercept. So this is the 1 unique solution. And you can guess what happens when the discriminant is less than 0. That means there is no solution, or the quadratic equation has no x-intercepts. And that looks like this. Something like that. This graph does not touch the x-axis, so it does not have any x-intercepts. Another version will be something like this. Okay, so there's 3 different scenarios that can happen when we have this equation. So if we do a question, for example, let's find the discriminant to, for example 1. Let's find the discriminant for y equals to x squared minus 6x plus 8. In this case, the discriminant is b squared, so negative 6 squared, minus 4a, which is 1, c, which is 8. This is 36 minus 32, which is 4. The 4 itself doesn't tell us anything. all we know is this number is positive, and therefore that means there is two solutions. Okay, we don't know what those solutions are, but the discriminant is a fast way of finding out if there is two solutions in the first place. And we'll go through examples soon where that will actually come in more handy. But in this case, if we want to work out what those solutions are for the equation 6x plus 8 equals to 0, we can factorize this. This is minus 4 minus 2 equals to 0. So x equals to 4 or 2. And these two are the two solutions to this equation. Okay. If we go through another example, example 2, and we try something along the lines of x squared plus 2x plus 10. In this case, our discriminant is b squared, 2 squared, minus 4 times a times c. That's 4 minus 40, which is negative 36. So in this case, there's no point in us trying to factorize this or use a quadratic formula. The fact that discriminant is negative means that there is no x-intercepts or solutions. So now let's go through a more specific example where we need to apply the discriminant. So example 3. Let's go through the question 3x squared minus 2mx plus 3 equals to 0. When you want to find out when is there, find the values of m such that the equation has, let's go A, one solution. Let's do that one first, and then we'll go through B and C. So, just to explain this first, we want to find the values of m. So m is given in the B term. So if m is 10, would that mean there's two solutions to the equation, or one solution, or 0 solutions, right? So what we're going to do first is find what the discriminant is. So discriminant is equal to b squared. So b in this case is negative 2m. It's whatever is in front of the x squared, minus 4 times a, which is 3, and times c, which is also 3. So that is 4m squared minus 12 times 3 is 36. So this is our discriminant. If we want to find out when there is one solution occurs when the discriminant is equal to 0. So we want to let 4m squared minus 36 equal to 0. If we do that, we get 4m squared equals to 36. M squared equals to 9. And that means m equals to plus or minus 3. So what we're saying is when m equals to plus 3 or negative 3, we have two solutions, or we have one solution to this quadratic equation. Secondly, we're going to do if there is no solution. If we want no solution, we need to do when is the discriminant 4m squared minus 36 less than 0. This is a quadratic inequality. I'll make a future video on how to do this in more detail, but in order to work out a quadratic inequality, we can't use algebra to do this. We can't do this, so we can't do this. So let me write up this. Don't do this. I'll write everything in red so we know not to do this. 4m squared is less than 36. M squared is less than 9. Well, actually, let me do it a different way. Let's do the more common way. I'm going to factorize the 4 out. M squared minus 9 less than 0. Divide by 4, which is 0 here. Up to this point, this is still correct. And then we can factorize using difference perfect squares. This is still okay. The mistake happens when we do this line. M plus 3 is less than 0, or M minus 3 is less than 0. M is less than negative 3, M is less than 3. We can't do null factor law for quadratic inequalities. We can't do this. Can't do null factor law for quadratic inequalities. What we have to do instead is to do a sketch of the graph. So let's put in blue. Do this instead. So first what we're going to do is we're going to do a little sketch of the graph. So we've already got an approximate shape of this graph. So it's m squared minus 9 with the 4 dilation. So it has a y-intercept around negative 36. Whoops. 36. Doesn't matter about the y-intercept too much. We just care about the x-intercepts, which one is at negative 3 and the other one is at 3. It's a positive graph, so it's going to look something like this. And what we do now with this graph is we look, when is this graph less than 0? So the 0 point occurs here. This is 0. So when is this graph below 0? When is the actual curve below 0? And the curve is below 0 in this region right here, i.e. between negative 3 to 3. So when is the discriminant less than 0? The discriminant is less than 0 when this is m, when m is between negative 3 and 3. That's our answer right now. Because when m is in that range, the curve is below 0, and that's what we want. We want when 4m squared minus 36 is less than 0. So that's when we have no solution. And last but not least, we have two distinct solutions. Two distinct solutions occur when the same graph is above 0. So if I just copy and paste this graph quickly, paste it in here. Okay. So when is this graph greater than 0? This graph is greater than 0 on the flip side, over here and over here. So what are the m values for that occurs when that occurs? The m values that occurs is any m value that's less than negative 3, for example negative 10, and any m value that's greater than 3, for example positive 5. So the answer, when is the discriminant greater than 0? Our answer is when m is less than negative 3 or m is greater than 3. And that's how we answer a quadratic inequality discriminant question. So in this question, we couldn't have solved this without using the discriminant. We'll do one more example to finish off. And that is, we want to show that the solutions of the equation, let's write the equation here, 3x squared plus m minus 3x minus m are rational for all rational values of m. It's a bit unorthodox way of writing something, but if I just get this and just make it a bit bigger, it's too big. Let's have a go at this question. So we want to show that the solutions for this equation, which has m twice, is rational. So first, what does rational mean? Rational means it can be expressed as a fraction, but yeah, can be expressed as a fraction is one way we can write a rational number as a fraction. But for the context of this question, it just needs to exist. It just needs to be real. It can't be irrational. And what are irrational numbers? Irrational numbers are surds, square roots of negative numbers, for example. Right? These are irrational numbers. Also pi. Pi is also an irrational number. Okay? So, what we're going to do is first find out the discriminant of this equation. So the discriminant is b squared minus 4ac. In this case, b is m minus 3, a is 3, and c is negative m. So the discriminant is m minus 3 squared, b squared, minus 4 times a times c. So we have m minus 3 squared plus 12m. We're going to expand this out. So m squared minus 6m plus 9 plus 12m. That's m squared plus 6m plus 9. If we then refactorize this, we actually end up with m plus 3 squared. M plus 3 squared is actually a quadratic that looks like this at negative 3. If you notice carefully, this quadratic is at 0 or greater than 0 for all values of m. And if the discriminant is greater than 0 or higher, that means one or two rational solutions occur. And we want to show it's rational for all values of m. So what we have to write is the discriminant is greater than or equal to 0 for all values of m. Therefore, one or two rational solutions will always exist. There's never going to be a situation where the discriminant is less than 0, and therefore there is no solutions to that equation. So that wraps up our discriminant lesson for today. Just to summarize again, the discriminant is b squared minus 4ac. It's used to determine the number of solutions to a quadratic equation. If it's less than 0, that means there's no solutions. If it's equal to 0, that means there's 1. And if it's greater than 0, that means there's 2 distinct solutions. And we can use that most popularly in questions using m to work out for what values of m do this or that equation have 1, 2, or none solutions. If there's any questions, please leave them in the comments. Thank you for watching.